CSM Instruments is a company that makes high-tech surface testing equipment. So we specialize in testing surface mechanical properties, and the three main groups are scratch testing for measuring the adhesion of thin films and coatings, indentation testing devices for measuring hardness or modulus, and tribology testing devices for measuring friction and wear. And today I'm going to be talking about our Nano Tribometer, which is a recently developed machine that has many advantages over conventional types of technology. An AFM uses a very sharp tip, and so it gives you very high resolution images. But if you try and use an AFM for measuring friction or wear, the tip is too sharp, and if you're applying a very low load, even with millinewton or sub-millinewton loads, the contact pressures are so high that you're going to be scratching the surface. So that's why we developed a system where we can apply the same load range as an AFM, but using an indenter which is much more blunt, so the contact pressures resemble what you would get in a real in-service situation. Well, linear reciprocation is used a lot for measuring friction in two directions. We can also do rotational motion, so standard pin-on-disc type rotational motion. But what's unique about the rotation is we have something called angular reciprocation, and that means you can actually set the angle over which you want to reciprocate, and it can be a small angle or a large angle, and in that way you can get frictional wear information over different arcs of a circle. So we have various different cantilever sets we can put on the machine, a low load, a standard, and a high load. So that takes the applied load from a maximum of 1 Newton down to millinewtons and under. So that means we cover a huge range of load, and then by using different friction sensors we can cover a huge range of frictional capabilities as well. So the most interesting point is that by combining different static partner geometries and different load ranges, we can actually go from gigapascal pressures down to sub-kilopascal pressures. So we're going from basically pascals to gigapascals. That's 9 orders of magnitude of contact pressure with the same machine. And that makes it extremely versatile because we can simulate contact pressures in all kinds of situations. Okay, the applications range from, there's a lot of bio applications obviously, where you've got very low friction. We also look at very thin films. Hard disks would be an example. So when you turn on or turn off your computer, the hard disk spins up, spins down, the head's going to hit the surface. The contact pressures are very low in some cases. We can simulate those. Another example I'll show you on the machine is connections. So in space applications, when a satellite docks, you've got very important electrical connections that need to be made, and the friction has to be controlled, especially in a space environment where there's obviously a vacuum or different types of oxygen available, to ensure those connections happen. And so we can simulate those actual contact pressures with the machine. We also use it a lot for studying lubricants, single molecular layers, diamond-like carbon films, which typically have very, very low friction and can be coated in maybe a few nanometers thick, can be used for studying that. This is the Nano Tribometer. What's special about this is the actual layout. We have two capacitive sensors, one for the normal force and one for the friction force, and both of these capacitive sensors allow us to have extremely high resolution for both the normal and lateral forces. So that's one technological advantage. You can see here on the left the cantilever. As I said, we have different cantilevers for different load ranges. So, for example, the high load cantilever goes up to 1 Newton. The low load cantilever goes down to sub-millinewton. So this gives us a very large range of applied load and also of the measurable frictional force. The other thing you can see, which is key, is the piezo here, which gives us active force feedback. And the advantage of active force feedback is that you're really applying the load over the entire cycle that you want to. So if you didn't have active force feedback, then you might be very susceptible to vibrations. If I knock the table, you would affect the data. You can see here it's extremely stable, because of the active force feedback loop. So if we look at the data here, you're seeing friction as a function of number of seconds or distance. You're seeing each cycle actually live, superimposed one over the next. So this is friction versus distance. And this allows you to analyze every particular frictional cycle, and we can actually export data at any particular time during a measurement. So it makes it a very flexible data acquisition system.